Alright, 2.2, we're going to be talking about the characteristics of these quadratic functions. In 2.2, we're actually going to be taking graphing a lot more seriously here, and actually being a lot more precise. Throughout this lesson, I want you to think about this word, symmetry. Okay? Symmetry is going to help you. Alright, this first problem says complete the table and use the values in the table to sketch the graph of the function. Okay, let's say on your homework you were given this function and I said graph it. I'm going to show you two different ways to do this. Number one, we can just plug in x values, right, and find out what f of x equals. So I would like to start with 0, right? When x is 0, when x is 0 in our function, we get 1/2 times 0 squared minus 2 times 0 minus 2. Right? This whole thing becomes 0, this thing becomes 0, we get -2. So when x is 0, f of x is at -2. So we're going to go with 0, -2. We'll use a red pen here, 0, -2. There we go. And then I like to work with 1 first. I like to work with the positives first. 1. So we're going to get 1/2 times x squared, which is 1. That's going to be squared minus 2 times 1 minus 2. Well, 1 squared is 1, so we're just going to get 1/2 minus 2 minus 2. 1/2 minus 2 is, what is that? -1.5. Minus 2 more is -3.5. So at 1, we're going to go to -3.5. One, 2, 3.5. 1, 2, 3.5. Okay. And then let's go to +2. I like to stay with the positives first. 1/2 times 2 squared minus 2 times 2 minus 2. A lot of 2's, holy cow. 2 squared is 4, 1/2 of 4 is 2. Minus 4, minus 2. 2 minus 4 is -2, minus 2 more is -4. So when x is at 2, f of x is at -4. Now let's start with our negatives. I'm going to do -1. So 1/2 times -1, that's going to be squared, minus 2 times -1 minus 2. -1 squared is 1, so we're going to have 1/2 times 1. Minus 2, so it's going to be +2 minus 2. That's 2.5 minus 2, which is 1.5. So at -1, f of x is at 1.5. And then how about when x is 2? X is -2, sorry. 1/2 times -2 squared minus 2 times -2 minus 2. -2 squared is 4, so 1/2 of 4 is 2. -2 times -2 is 4, so that's going to be +4 minus 2, which is 4. 2 plus 4 is 6, minus 2 is 4. -2, 4. I must have messed up there. 4, 1/2 of 4 is 2. Plus 4 is 6. Minus 2 is 4. Oh, yeah, that's -2. I must have messed up on -1 somewhere. Let me just do it quickly. I'll pause the video here so I can. Okay, I did make a mistake on -1. The reason I know that is because when I look over here at my graph, this point right there is kind of off target. It looks a little goofy. There we go. When x is -1, I did the math at 0.5, which actually will look a lot better. -1, 0.5. Yeah, that looks more in line with my other points. Good. And then they want us to do 3, 4, and 5. 5 and 6. I'll probably just do 3 and 4 here. Let's do 1/2 times 3 squared minus 2 times 3 minus 2. 9, 1/2 9 is 4.5 minus 6 minus 2. That's negative 1.5. Minus 2 is negative 3.5. Negative 3.5. So when x is at 3, f of x is at negative 3.5. Okay. How about when x is at 4? And hopefully we're going to get the pattern here. How about when x is at 4? 4 squared minus 2 times 4 minus 2. At 16, 1/2 of 16 is 8, minus 8 minus 2, which is 0, negative 2. So when x is at 4, f of x is at negative 2. Hey, we've seen that point before. We've seen that point before at 0. At 0 is negative 2, at 4 it's at negative 2. Hey, we've seen negative 3.5 too. When it's at 1 it's at negative 3.5, when it's at 3 it's at negative 3.5. Okay, are we seeing a pattern here? What do you think it's going to be when x is 5? Well, it should be whatever this point was, right? Which is at 1.5, or 0.5, sorry. And then when it's at 6, it should be up at 4. Okay, we can do the math and check it out, but I guarantee that's what you'll get. There is our quadratic function, our parabola. A lot of work there. A lot of work. One, because we had to find the vertex. Where's our vertex of this parabola? It's at our lowest point, right here. It's at 2, negative 4. Vertex. 2, negative 4.
Caution now, please hold 26.
Okay. Instead of writing out a bunch of points and then graphing randomly, trying to find our vertex, which, what if our vertex is at 12, negative 18, right? It'd take us forever to get there. Here's the way you can find the vertex using when a graph is in this form, x squared plus x plus a number, whatever it is, okay? Use this form. Negative b, oh, sorry, messed up. Not negative b minus 2a, negative b over 2a. Negative b over 2a. Okay, negative b over 2a. Each of these numbers in front, this like 1/2, that's a. This negative 2, that's b. This negative 2, that's c. A, b, c. That's how we label those. So we're going to have negative b, which b is negative 2. So we're going to have negative 2, which just becomes a positive 2, over 2 times a. Well, what's 2 times 1/2? That's just 1, right? So we get 2. Okay, that's what x equals in our vertex. To find our vertex, that's what x equals. So x equals 2. Now what we're going to do is we're going to plug in 2 for each x. And we should get -4. Okay, and we plug in 2. 1/2 times 2 squared minus 2 times 2 minus 2. A lot of 2's. 2 squared is 4. 1/2 of 4 is 2. Minus 2 times 2, which is 4. Minus 2. 2 minus 4 is -2. -2 minus 2 is -4. That's what y equals. Y equals -4. Hey, our vertex is at 2, -4. Okay? That's just one way to find our vertex. Okay? And then I will use that information here shortly and describe how we can graph from there. Makes it a lot easier than just trying to plot a bunch of points trying to find a parabola. Okay. This part here says show that the vertex form f of x equals 1/2 times x minus 2 squared minus 4 is equivalent to the function given in part A. Where's the vertex of this function? We know this. We know this nice equation here. Because what moves our vertex? Only this and this. This moves it right 2 and down 4. So what's our vertex? 2, -4. Same vertex. Down here. Okay. They're saying these 2 equations equal each other, but let's say we were only given this equation. I'm going to take my time here and explain this in depth to you. I'm not going to use this. That, to me, is a waste of time. I know way more than just plotting a whole bunch of random points. What I want to do is I want to find the vertex. How do I find the vertex? -b over 2a. This is a, this is b, this is c. We're going to get -2 over 2 times 1/3. Okay, so we get -2 over -2 thirds, which is a weird looking fraction, right? How do we get rid of a fraction in a fraction? Multiply by the reciprocal. Okay, so this cancels out to be 1, right? 2 over 2, -3 over 3. So we get 1, and on top we get 6 over 2, which is equal to 3. Okay, again, just to recap, I multiply by the bottom reciprocal, so this should cancel out and be just 1. Right, now when I multiply -2 by -3 over 2, it's like this, -2 over 1 times -3 over 2. We multiply straight across, so we get 6 over 2, which is equal to 3. Okay, that is what x equals. So x is 3. We need to plug that back in to find y. So we're going to plug 3 in to find y. Y, or f of x, equals -1/3 times 3 squared plus 2 times 3 plus 3. 3 squared is 9. -1/3 of 9 is -3. Plus 2 times 3 is 6. Plus 3. We get 6. So our vertex is at 3, 6. our vertex is at 3, 6. This is our minimum and maximum. I asked you at the beginning of the lesson. This is actually it's going to be the maximum because our graph is flipped over the x-axis. So our arrows will be pointing down. So that's our maximum point. I asked you at the beginning of this lesson. Think of symmetry. Okay, our axis of symmetry of this graph goes right through my vertex. Okay? My axis of symmetry is x equals, it's this line, it's this vertical line, right? If I went, or we'll do this first, it's x equals 3, whatever your x equals, that's your axis of symmetry, that's your line. If I go in here and type in x equals 3, watch what happens. It's a vertical line, right at 3. X equals 3, vertical line, right there, okay? There's my description for you. Instead of plotting a whole bunch of random points, I found my vertex, I know my axis of symmetry. I want 2 points on the right of that axis of symmetry, and I want 2 points on the left. From there, I can graph. Okay, so I'm going to create an x in Y chart. I'm going to put 3 right in the middle. Well, we know what f of x is when x is 3, it's 6. Okay? Now I'm just going to do 4 and 5. Watch how quick this is, okay? Now, plugging in 4 and 5 might take a little bit. Let's see how we do. Negative 1/3 times 4 squared plus 2 times 4 plus 3. 4 squared is 16. So we're going to get negative 16 over 3 plus 8 plus 3. So negative 16 over 3 plus 11, which is 33 over 3. Okay, that's 11. Negative 16 plus 33 is 17. Yeah, 17. So it is 17 over 3. 17 over 3 is roughly what? 5 2/3. So when x is 4, we're going to get 5 2/3. 5 2/3, right? About there, 5 2/3. 5.6. Okay. Hey, good thing. Axis of symmetry, right? When x is 2, guess what we're going to get? 5 2/3. Oops. 5 2/3. Now we only have to find one more number. So you really only have to find the vertex and then 2 points. That's all you need. Because then 2 other points you get for free. I'll even plot that point. And now it's kind of a pain to get these, right? Negative 1/3 times 5 squared plus 2 times 5 plus 3. We get 25, so negative 25 over 3 plus 10 plus 3 is 13. So we'll get 39 over 3. Negative 25 plus 39. What is that, 14? 14 over 3 is roughly 4 2/3. We're going to say 4.6, and then when x is 1, it's 4.6. Okay, now this is a tough example. 5, 4.6. 1, 5.6. 4.6, sorry. Here we go. Done. Now, that was a tough example because we had 1/3, right? That's nothing fun. if you're given this equation right here, we can find our vertex right away. Right 3, up 6. Right 3, up 6. Done. Here's my vertex. Okay, now I got to find 2 points. I want you to find at least 2 more points. Okay. You could say, well, how about, so we know when x is 3, we're going to get 6. So when x is 0. How about 0? Let's plug in 0 for a change. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 times negative 1/3 is negative 3. Negative 3 plus 6 is 3. 0, 1, 2, 3. Okay, how many points away is that from 3? That's 3 over, so how about 6? Guess what you're going to get? 3. Okay. Now, that's only 3 points. I want at least 5 when graphing these. But just so you know, when we get this equation, it's going to be a lot easier to find our points. Okay? What type of symmetry does a graph of the parabola? Well, it's always our vertex, right? Right? H up K. Actually, our symmetry is always going to be x equals whatever H is. Yeah? Whatever H is. That's our axis of symmetry when given that graph. Describe the symmetry of each graph. So, where's our vertex? It's at 1. So what is our axis of symmetry? X equals 1. Done. This one. X plus 1. It goes left 1, down 2. We don't care about that, down 2. We just know that our axis of symmetry, X equals negative 1. How about this one? Wherever that thing in parentheses is. It's the opposite. This one. Ooh, tough one here. Tough one. There's nothing in parentheses. So does it go left or right? Nope. So, right through the middle. How about this one? Done. This one, E, part E. Part E. If you were given an equation, okay, then you'd have to use the form negative B over 2A. But since they're missing this middle term here, they just have 2x squared plus 3. That's in quadratic function form. Sorry, I forgot the term of that. That's in vertex form. Negative 2x squared plus 3. Okay, so since it's missing that middle term, there's nothing in parentheses. It's just x equals 0. Moving on. Axis of symmetry. It's the line that divides your parabola in half. Okay. Always x equals our whatever our vertex x is. X equals h. Okay. Standard form. Standard form. This is standard form, so not vertex form, it's standard form. Ax squared plus bx plus c. That's what we talked about earlier. To find our vertex here, we have to use negative b over 2a. That's how you find our vertex. That's how you find x. You gotta plug x in. So I'll even say x equals negative b over 2a. The minimum value. The minimum value I think it's better to draw pictures. Okay. The minimum value. If I have a graph and I have a parabola that goes like this, my minimum value is where my vertex is. It's always going to be the vertex. Either the minimum or maximum value. The maximum value is opposite, right? So if I have this graph, graph goes down. And my vertex right here, that's my maximum value, the maximum amount my line can reach. And then intercept form. Intercept form we haven't seen before. Intercept form is A times x minus p times x minus q. Okay. Where A can't equal 0. So A is not 0. That's intercept form. We'll go through this here shortly in an example problem. Okay, properties of the graph. Ax squared plus bx plus c. X equals negative b over 2a. Plug it in. Find your y-intercept. Vertex form. Right here. Okay, I'm going to try to make sense of this. We'll go through it in a minute. It's a poor example. Graph the function. Label the vertex and axis of symmetry. Find the minimum or maximum value of the function. Describe the domain and range of the function. Where the function is increasing and decreasing. Okay, so there's a lot going on. Let's just find our vertex. Our vertex of this first one is at -1. Okay, -1. Now we got to create our x and y chart. We got to come up with two numbers above that, so 0 and 1, and two numbers below, -2, -3. When x is at -1, y is at 0. Oh, and x is at 1, or 0, sorry. 0 plus 1 is 1, 1 squared is 1, so 0, 1. When x is at 1, you get 2 in there, and then you get 4, so 1, 4, 1, 2, 3, 4. And now guess what? You don't have to even do the math for -2 or -3. You just go on the other side of that axis of symmetry. Right there. Okay, so this point up top at 1, 4 is 2 away from my axis of symmetry, so I'm going to 2 on the other side. There we go. There's my parabola. The minimum is at 0, or sorry, not 0, -1, 0. And then describe the domain. My domain. Where is my graph going? Well, the further up it goes, the further up it's going, the further away from 0 it's going, right? Your domain for all of these is going to be this symbol. That's all real numbers. If you want to say all real numbers, you can, but that is our symbol for all real numbers. Our range is going to be the only thing that's different. Our range doesn't go left or right. Our range goes up and down. And our graph doesn't even touch down here. Right? So our range is y, we'll do it here. F of x is greater than or equal to 0. Okay? Because it is equal to 0 at our minimum point, and it's also greater than. Okay, increasing, decreasing, I really don't have, we don't really have to describe that. How about this one? This goes right 4, down 5, so right 1, 2, 3, 4, down 1, 2, 3, 4, 5. Okay, there's my vertex. My axis of symmetry is what? X equals 4. Sorry, this was x equals -1. Now we have -2 in front. We don't have any room, but our graph's going to go down here. Okay, if it's on your homework, I do want you to graph those points. Right now, we're kind of making this video a lot longer than it needs to be. So right now, I'm just going to skip ahead. I'm just going to talk about domain and range. Domain, what is it? All real numbers. Your range, well, it doesn't go above what number? -5. So our range is f of x, or sorry, this is actually y. This equation is y. I'm losing it. Sorry. Be done quickly. Y is less than or equal to -5. And then I'm just going to do the domain and range of this one. First, we have to find the vertex, -b/2a. So we're going to get +3/2 times 3/2, which is 3/6/2, which is 3/3, which equals 1. So x is 1. So our axis of symmetry is x equals 1. There's an answer. We got to plug in 1 to find our y. So 1 squared is 1 times 3/2 is just 3/2 minus 3 minus 1. Well, -3 minus 1 is -4. So we have 3/2 minus 4. We do that math. I'm going to say 4 is 8/2. Equals -5/2. So at 1, -5/2, which is like 2.5. Okay, and this graph is positive. So it's going to be going up. My domain, all real numbers. My range is f of x, which is greater than or equal to -5/2. Okay. These last couple are on you.